The tabular method works best when f of x can be differentiated repeatedly to become zero, or u as a polynomial function, and gx can be integrated repeatedly without difficulty. How does it work out? For this example, the integrand is x squared times e to the x. Identify x squared as algebraic function, which is also polynomial function, e to the x as the exponential function. So u as the x squared and dv as e to the x. Form the table. The left column is the column that we're going to find the derivative. The right column is the column that we're going to find antiderivative. The left column, put the u term, which is x squared. The right column, put the e to the x, which is the dv. And then complete the table by finding the derivative all the way to 0 for the left column to get 2x, 2, and 0. So there are 4 rows for this table. And then finish off by finding the antiderivative of the right column. Antiderivative of e to the x is e to the x. And then keep going, keep going. And then we use the product of the first left and the second right, and keep going in this way. The first product, we put plus sign, next minus sign, and then plus sign. The sign will alternate, starting from the plus sign and so forth. Therefore, the antiderivative of x squared e to the x dx is from the product of x squared times e to the x with the plus sign, and then minus sign, the product of the 2x and e to the x, and then plus sign, the product of the 2 and e to the x, and then plus c. In this example, is the definite integral of x to the third times cosine 2x dx evaluate from 0 to pi. We have the function x to the third identified as x to the third as algebraic function, and then the cosine 2x as a trig function. X to the third is polynomial, so we can treat it by using the tabular method, and cosine 2x is the dv. With the tabular by parts, the left column, we're going to find the derivative. The right column, we're going to find antiderivative. For the left column, starting with the u, which is x to the third, the right column, cosine of 2x. Next, find the derivative of the left column until we get 0. So we get 3x squared, 6x, 6, and then 0. On the right column, we're going to find antiderivative of cosine 2x. The antiderivative of cosine 2x would be sine of 2x. And with the u sub, we would get like 1/2. And then keep going with the same way. We're going to have 1/4 cosine of 2x with a negative sign. And then a couple more times to get 1/8 sine of 2x. And the last one will be positive 1/16 cosine of 2x as the antiderivative of negative 1/8 sine of 2x. And next, we're going to use the product x to the third and 1/2 sine 2x, 3x squared and negative 1/4 cosine 2x, 6x times negative 1/8 sine of 2x, and the last product 6 times 1/16 cosine of 2x, and the sign of each product starting from plus sign, minus sign, plus sign, minus sign. Now, we have the antiderivative from 0 to pi of x to the third of cosine of 2x dx as the first product. We have x to the third multiplied by 1/2 sine 2x, minus 3x squared multiplied by negative 1 over 4 cosine of 2x plus sine 6x times negative 1 over 8 sine of 2x minus sine 6 multiplied by 1 over 16 cosine of 2x and evaluate from 0 to pi. Let's clean up a little bit before we plug the numbers in. We have 1 over 2 x to the third sine of 2x plus 3 over 4 x squared cosine of 2x minus 3 over 4 times x times sine of 2x minus 3 over 8 multiplied by cosine of 2x with the lower limit 0, upper limit pi. Replace with the upper limit to get 1/2 pi to the third times sine of 2 pi plus 3 over 4 pi to the second times cosine of 2 pi minus 3 over 4 times pi times sine of 2 pi minus 3 over 8 times cosine of 2 pi, and then subtracted by the value from substituting the lower limit, going to be 1/2 times 0 sine of 0 plus 3 over 4, 0 squared, which is 0, times cosine at 0, minus 3 over 4 times 0 times sine at 0, minus 3 over 8 times cosine at 0. So for the case of sine of 2 pi, that's 0. Sine of 2 pi is 0. Cosine at 2 pi, that's 1. Sine at 0 gone. 0 multiplied to anything, you get 0. But cosine at 0 is 1. So let's clean up a little bit. So the first group, we still get 3 over 4 times pi squared. And then minus 3 over 8 multiplied by 1, which is negative 3 over 8. And subtracted by negative side becomes positive side of 3 over 8. Therefore, the answer is 3 over 4 times pi to the second. Let's see another example of the tabular technique. The integration of 3t divided by e to the t from negative 1 to natural log 2. We write this as the product of the two functions. We will get the integration from negative 1 to natural log 2 of the 3t multiplied by e to the negative t with respect to t. Use LEAD to identify the type of the functions. 3t is the algebraic. E to the negative t is the exponential function. And since 3t is a polynomial, let it be u, so the tabular technique will be appropriate or is convenient for this case. The left column, we're going to find the derivative. The right column, we find the antiderivative. In this case, for our convenience, I'm going to take 3 as a coefficient outside of the integration. So 3 times the integral of the t times e to the negative t with respect to t. Therefore, the function u is just t. So t as the u function, and find the derivative to get 1, another derivative to get 0, and then close the table. The right column, starting with the v, with the dv, which is e to the negative t, and then find the antiderivative of the e to the negative t, which is negative e to the negative t. So this one is the antiderivative of e to the negative t dt. And then keep going, we get the next round as e to the negative t, which is the antiderivative of negative e to the negative t dt. And then we pair them up as a product. So t times negative e to the negative t with the plus sign in the front of their product. And the next product has a negative sign. So for our case, the integration, which is 3 multiplied by the first product, which is t, multiplied by negative e to the negative t, minus sign 1 multiplied by e to the negative t, and then evaluate from negative 1 to natural log 2. As we see the common negative 1, pull it out from the group, we have negative 3 outside, and we have the expression t times e to the negative t minus e to the negative plus sign e to the negative t from negative 1 to natural log 2. Substitute the value. The first group replaced with the natural log 2. So we have natural log 2 multiplied by e to the negative natural log 2 plus e to the negative natural log 2. And then subtracted by negative 1 multiplied by e to the first power plus e to the first power. Negative e to the first, positive e to the first. So this group will be 0. And we call the negative power is the reciprocal of the positive power. Then we get negative 3 natural log 2 multiplied by 1 over e to the natural log 2 plus 1 over e to the natural log 2. And e to the power log 2 is 2. Then we get the answer as negative 3 times natural log 2 over 2 plus 1 over 2. Or rewrite it as negative 3 over 2 multiplied by natural log 2 plus 1.